So today we are going to dive a little deeper into OOP and see what functionality it offers us. So first thing that we're going to be talking about today, and this is a new topic, it's called decorators. So just a reminder, yesterday, we learned how to create a class, instantiate a class. We learned also how to create instance attributes and class attributes or class variables. And today we're going to be learning about a few other things. So decorators is one of them. And then we're going to be talking about different types of methods within a class. And then lastly, we'll talk about getters and setters, which will allow us to get data and retrieve data in a certain way through classes. Okay, so decorators are basically functions that allow us to modify the behavior of another function when we define that function. It is not essential that we learn how to make a decorator, but you will be using it quite a bit. You'll use it a little bit now, even more so when we move on to Django and we're working with the functions in there. So yes, so like many programming languages, Python has something called a first class function. So first class functions basically mean that the functions can accept other functions as inputs. Also, they can return functions as output. So before we talk specifically about decorators, we'll just kind of see an example of that happening. So a function making another function and returning it. So let's say we are making widgets at our company, and we need to create a few different types of widgets with different colors. And so let me just define a widget maker. Oops. And then this widget maker, let's say for simplicity right now, it's just returning an object. Don't worry really about the implementation, but let's say typically we have something more robust here. So type, let's say this is a widget. And then our color will be something that we actually pull in from the function. So this function takes in a color and we assign it here. So if I wanted to create a red widget, we can just call widget maker and send in red. And then if I print out red widget, it should be just the object itself. Make sure I'm in the correct directory. And then we can run. Oops. There we go. So we got the object that we returned. If we were to change this, obviously it would change as well. There we go. Okay. So let's say we want to actually return a function that creates a certain color widget. So let's say this function doesn't take anything here. And we need a color to come in, and that way every single widget that is created, we can have the maker make a certain color of widget. I know it sounds a little confusing, but hang in there. So widget maker, and then you can send in a color. So then we're using this color to create this. And now, if I want to say, I want a function, or I want a function returned to me that will actually create red widgets for me. So okay, so I'm going to call this red widget maker, and I'm going to call the widget maker with the color red. And so when I call this function, it goes in here, it creates a function for me, and then I need to return this function. So this way, when I say, give me a red widget maker, it is actually going to create a function for me that has a specific color set inside of this function. And now every time I call this function after it was returned, it will create a widget with a red color for me. So here I can just say my red widget. So my red widget can be, I just call my widget maker and not have to send in anything, and then it will create a widget for me. And if I wanted to say another red one, then I could also call red widget maker. And I didn't print it out, so. And here we got two of the same. So this is just to help you understand the idea of a function that returns another function. So when this function returns this function, I can actually use this, use it in here to call it. So I called this maker with a certain color. It created a function for me. This is holding a function now because that's what it returned. And then I can call this function to then return the object that I want. And if I call it over and over, it will do the same thing. So you won't see this a lot in the wild, but sometimes it is helpful if you have a bunch of functions that do the exact same thing, but like one tiny detail is a little different. You could create a function that will return the function based off of like the one variable that you need to change, or the one little detail that you need to change. Any questions on this?
Yeah, which one would be considered the first class function? Would it be widget maker, or the thing inside, the definition inside that one?
So technically all functions are first class functions. But this one,
Okay.
technically the one that is doing or having that behavior, because it is returning a widget within it, or sorry, a function within it.
Thank you.
Mm-hmm. Other questions?
Was the first example you were just returning an object
Mm-hmm.
Okay.
Yeah, I was returning an object using this. So basically, let's say I wanted to do like a few different colors, like there's only red and blue ones. If I created just one red maker and one blue maker, I can create as many of these as I want that have the same value. So like this one, they're all going to be blue. So here they're all blue. And instead of having to send in the specific information to every single time I want to create a new widget, I could just set it up from the beginning, be like, hey, return me a function that will do this. And now I can call this function to do exactly what it needs to do without me sending any extra parameters.
Well, I missed the first part. So without define widget maker, what were you doing first?
Before this one?
Yes.
So this one was the original one. I wrapped it in another function pretty much.
Okay.
That return, yeah. So this function is basically like a wrapper function, and this will now return this function here. Let me see. Questions in the chat that I've missed?
I have a quick question.
Uh-huh.
So I'm trying to like come up with a good use case, like when you said that if they vary differently. So if like, were you referring to the return object like type and color? So could we use like a conditional statement and then return that function depending on conditional?
Yeah, you could, yeah. Exactly. So like right here, it's just taking the color and inserting it here. But if you wanted to have, if it was a more complex thing, you can maybe put the type here. You can take in like, what am I creating? And then it would return a certain function based off of that type or something like that. Or even
Cool,
by,
thank you.
oh, of course. I'm not sure if on a large scale this does save memory. Passing another parameter. Yeah, why not just pass red or blue to the widget maker? This is, yeah, I don't have a good example for you guys. But yeah, this is a very simplified like classroom example of something, just to demonstrate that a function can return another function, and then you can use that function to be called later on. Yeah, that's the full takeaway out of this, because we haven't even talked about decorators yet. So that's when I think we will understand why. So decorators, decorators are basically functions that will allow us to modify other functions. So typically they act like a wrapper around the function. So they will take in a function and then return it, and we'll see exactly how it is. But from this example, just understand we can create a function within a function, we can return that function as well. And this function or any function could also take in a function in Python. Yeah, that's the takeaway. Other questions? Okay. Awesome. So yeah, sorry. Okay, so typically we don't want to write.
I have a quick question.
Yeah.
So the line 14 and 15, can we make just to one line, like the red reach equal the maker and remove?
And remove these?
I mean, see these two lines, because we use the red reach maker equal the function, and then use the red reach equal red reach maker. Can we just make to one line, use red reach equal the reach maker?
Yes, maybe. So in that case, we would have to call. So okay, so when we call this, it returns a function. So it doesn't return an actual widget, it returns a function that can make widgets for us. So that is why we have to use this to then call it. I think if you do this and then add this after it, so it will call whatever function that returns, it might work. Okay, so that did work. I'm gonna comment this one out. Oops. Yeah, so this one would work. You can do it in one line, but you would have to remember, like, this looks a little more confusing than understanding that this thing returns a function, and then you can call that function on this line.
Okay,
Yeah,
thank you.
of course. There we go. Any last minute questions? Okay, so it's cool to understand that you can have functions that return functions, and you might use it. If you have a lot of redundant functions, you might not. But a use case that does use this feature in Python are decorators. So I'm gonna kind of walk through and show you how a decorator can be created, just to understand that when we use it, what is actually happening to this function that is decorated. So let's see. So let's say we're trying to improve the performance of a slow application that we have. So let's say the functions in this application are, I know these are simple, but add 1 and multiply by 2. And we wanted to pretty much improve the performance. So we want to print out the time every time the function is called, just to understand, like, how long is it taking from one function to the call to the next. So let me see. Okay. Sorry. Function. Okay. So let's say we want to define a function that will print current time and also do something else. We can actually start with just wrapper function. Okay, so let's say we have sorry. Sorry, give me one moment. Okay. So let's say we want to call this function and we want to print out when the time is happening. So if I want to do that, I could either add this print time in every single function that I have, or I could use something called a decorator. So let's say for now, I'm going to print out the function name using this. Does that work? Hopefully. So I'm going to call this dunder name, should apply to the function itself. I'm going to import datetime. So datetime will give me the time. Oops, date time. Okay. And consistent use of tabs and spaces, so I can just go back here. Okay, that fixed it. So let's say I want to add 1. And then I'm going to send in 5. And I'm going to print out the solution. Datetime, I think it's from datetime, import datetime, but it's like a double nested. Okay, so the datetime.now will return the current time or the current date and time. So awesome. So when I called this function, it says it's going to print. This is supposed to be like the name of the function, but this is not working. So let me just say calling add 1 at this time. And then it returned 5 + 1, 5 is 6. Okay, so I can do this. I could add a print statement in every single function, but let's say I have like 20 functions in my code. Having that exact same print statement over and over is not going to be great. It will clutter your code, and it can be done in a more elegant way. So let's put this into its own function. Okay. I'm going to say, I'm going to create something called a wrapper function. I'm just calling it that. So this function is going to take in any arguments. So args, what was it? So if you guys remember, when we do star args and star keyword args, so this means that this function can take in literally any sort of arguments that is sent into it. And then we're going to use this function to wrap around, what is it called? Sorry, the example in this lesson is not like well organized. So some topics will have to be talked about before others. Okay, let's forget about this one. Okay, so we will define a function that is going to print the current time. And also do something. So we want every single function, that shouldn't have run. We want basically every single function to be wrapped with a print statement. So we want to print something. We want to, not something, but we want to print that date, this one that we're calling which function, and when it started running. We want to do that around the function itself. So let's say this one will take the function that we are going to run, and then it could return, let's see. Okay, so it'll take the function. We will print out that we are calling this function by its name. So this will just print the function's name, and the date time. And then we will return the function as it's called. So we will call this function. And we need the arguments that go into the function. So this is the reason why we need a wrapper. So basically, if I want to just call add one, I can't really do that and have it also print the current time. So I'm going to create a function within this that will be returned. So that way I can run it with the arguments that I was going to send into the function itself. And it will run the function for me with the arguments that I need. So this is where this comes in. I promise it will make sense soon. Okay. So I am going to not return the function. I'm going to return this wrapper function. So similar to what we did up there, where we created a function that was returned. So this is now going to, whenever we return this, we can use it to call the function that we wanted to call in the beginning. But the only difference is that it will actually print out this before it calls the function. So now from this one, we can return the function call, and we can actually send in the arguments. So the reason why we're doing the arguments like this is to keep it generic. So that means this wrapper function should work for every other function that we have, even if, like, no matter how many arguments that it has. Okay, so why did we do all of this? So now we can define a function. We can say print current time and also add one. I know this is a very long name, but it is very descriptive. So we want to print current time and also add one. So we want to have it use this function to run and also print the time. So how do you think we would, which function would we call to make this function for us? And what parameter would we send in?
Use a print current time and also passing add one.
Exactly. So we're going to call this function. This function takes another function as a parameter. And then we're going to send in the function that we want the behavior to be modified of. So we don't want it just to add one, we want it to also print. So I'm going to send in add one. So now, because this function returns a function, this has become a function that will, when it's run, it will go through here, right? We can send in whatever parameter our original function needed. So our add one function, it needs a number, so we have to send in a number. And so when this function is run, it will run this line, it will print the function's name, it will print the date, and then it will return the results of us calling that original function. Because when we defined this, we sent add one as our function. And when this function returned for us to use here, it used that same function that we sent in. And now every time we call this function, it will return the result from this. So the way I can do this is, I'm going to put it in a variable. So this is like 5 plus 1 equals print current time and also add one. And I would need to send in a number, because that's what this add one function does. And I can send in a 5. And now if I print out 5 plus 1, it says it's calling add one at this time, and then it printed out the value here. So basically, this function is decorating the inner function, or like this way of doing it adds, what is it called? Adds certain functionality to the function call itself. So the actual, if we just wanted to add one, we would have said add one, and then we sent the parameters, right? This is the main event here. But because we wanted to do extra stuff, this decorator is wrapping the function and returning a function that we can use that has specific properties or specific extra things that it's doing. Questions about this? Okay. So this can be done the same thing with the multiply by 2. So if I just used, if I use the same set of commands, so I'm just creating a function out of this, and then I'm using it here. So this is how decorators are kind of implemented. So now I'll show you the easy way of how we actually use these decorators. So let's say I have a function to subtract 3 from a number. So the way we use these decorators, so this is the decorator that was created. So all we have to do is put an @ sign and say print current time and also subtract 3. So this is anything with an @ sign, that's the symbol for a decorator. So this function is decorating this. So basically what it does is it modifies the usage of this function. So it will send this function into here, which is what we did here, right? So this function goes into this function here, and it modifies and returns a slightly different version of that function when we are actually calling it. So now if I do, all I would have to do is say subtract 3. Also, this is supposed to be lowercase. Subtract 3, and I send in the number. So let's say 5. And now I print out the result of this. It says calling subtract 3, and it gave me the answer here. So basically, you don't have to do all of this. You don't have to like pull the function automatically and call it. Decorators do this automatically for you. So we typically will use the decorators that are created for us. We're not going to write this on our own, but this is just to understand what is happening under the hood. So a decorator will take the function that it is decorating. It will slightly modify the behavior of that function based on what this decorator does or what it wants to do. So here we want to print current time and also do like execute the function. So that is exactly what's happening. So when I just called subtract 3, it printed the time, and then it printed the result. So if I didn't have this decorator here, if I just run it, I don't get the print, but it does subtract 3, but it doesn't actually print the current time and do anything else. Questions?
Yes. Does the decorator only add to subtract 3, or if you add another function like underneath it, you know, like a subtract 4 function, would it be included with that one?
It will not be. So you have to add it to every function that you want decorated.
And it's only added by being directly above.
Exactly, directly above it. Yeah.
Okay, thank you.
And I believe you can chain them, so you can have like a few on top of each other, and it would do something similar. I mean, this is not what I want to do here, but yeah. you can use multiple ones. And then if I subtract 4, yeah, I would have to have the decorator above function that I needed to modify. Other questions? Of course, yeah. Other questions?
Yeah, so does the print current time and also, does that just grab the first thing it can grab and then go into print current time and also? Or like how
Does it grab what?
the first thing it like, that's next to
Yeah, first function.
grab? Okay, so they have to be like really close to each other, I guess you could say.
Yeah.
So that it grabs what you needed to grab.
Yeah, so decorators will always live on the line above the function definition. So this is where this function is defined. You have to decorate it right above it.
Oh, so you don't have to do like with line, I guess, 38 or 37, you have to.
No.
Those are unnecessary. You can just use the decorator and you have to use the @ symbol so that it knows. Okay.
Yeah, so we could have done it this way, but it's so much easier to just call the function with its normal name, and just have a decorator that modifies and does whatever I need it to do above it. So yeah, all of this stuff is not needed because we are putting this decorator here.
Thank you.
Yeah, sorry, the beginning of it was a little rough, just because I couldn't find like a natural way of showing the two different functions. But does it kind of make sense now?
I kind of have a quick question regarding decorate, like, so the use of decorators could be used for, so the decorated function returns one result, like that function has a specific role. Would the decorator be like a side effect that you want to happen, or have something happen to keep the code, I guess, more clean? So the decorator would have a side effect that would trigger every time the function was called. And so it's like, update users or whatever. So every time you subtracted a user, the decorator would reach out to and subtract something else, but like use it as a side effect. I'm guessing.
Yeah, I know. Yes.
Or is that a use case?
No, I think that's mostly what it's used for. We'll see a few applications today. So we had to.
Okay.
Yeah, we needed to talk about the decorators because we're going to be using them when we're creating the different types of methods and stuff like that, and getters and setters. So yeah, they are usually used for like side effects, or if just to give the function extra functionality that is kind of like built-in factory made. Like you can use this out of the box if you just put the decorator on top.
Awesome, thank you.
Of course. Yeah, any other questions?
I have a question. I guess I don't really expect it to be explained again. But can you send in 2 arguments? So like if you had like a defined multiply function where you wanted to multiply a number by some other multiple.
Yeah.
You also send in, does this decorator work, or do you need another decorator that has the same understanding of how many arguments it's taking?
Let's test it out. So we're going to say it's going to take one number and then another number, oops, no, 2. And this will then return num1 multiplied by 2. Oops. Okay. And if we just copy this decorator, and then we say multiply, oops. forgot my parentheses. Okay. So this one, let's say it's 5 and 3. So it does work. And so yeah, it does the print, and then it actually prints the result. So looking at this code, this is because this is the decorator code. What do you think allows us to send in whatever parameters we want? What's the thing that handles that?
The star args.
Exactly. So this will handle any sort of argument, and all it does is it's going to take all the arguments that were sent in, and it's going to pass it down to the function that it needs to call. That's pretty much it. Yeah.
Okay.
Awesome. Great questions. Other questions?
So I've got a question about that star args then.
Mhm.
So it's just basically passing those through to the function that it's wrapping, right?
Mhm.
What if those arguments don't line up with that function then? You
Then
know,
you'll
like
get
you're-
an error based on that function. So
Okay.
when this function is called, it'll go into the function, it'll check, do I have all the arguments that I need? If not, it'll cause an error. So let's try it with the multiply one. So here it says multiply missing one required positional argument, which is number 2.
Right. Okay, that makes sense. Thank you.
Yeah, of course. Keep them coming. Other questions?
So for this example, the decorator is only for like passing one function, but could you pass multiple functions, or you just need to pass one function? And within the other function that's like handling it, we have multiple functions in there, or like, how does that work?
I'm not sure. I think you can do it. I'm not sure how it would work with this syntax, like to add it to multiple functions like that. Because this one is automatically just taking the one function that's below it. So
Okay.
that means that print current time and also will always have to take one function, because I don't think you can apply this to multiple functions like this. But if you were writing this decorator not to be used like this, and just to be called like these two examples here, you could probably call both functions. So you can have add one, and then you can send in, I don't know, subtract 4. And then this one would have to take function 2. Subtract 4 is not defined. Oh, it's because it's below it. So multiply by 2, let's say. And yeah, so you can do this, but I don't think it would work with this decorator like syntax.
Okay, I think I understand. Thank you.
Yeah, so in theory it would work to do this, to create a decorator, but I don't know if you can use it using the syntax. Other questions? Okay. All right, so now we've talked about decorators. Let's gonna change the name of this real quick to decorators. And can't spell attributes. Okay. Any last questions about decorators before we move to the next one? Okay. So this is just a recap of yesterday. We can instantiate, let's remove the legs one. This is a bad example. But we can create a class, define it with the capital letter that it needs. It doesn't need it. This is more of a convention that is known like among developers. So if any developer looks at code and sees a capital letter, they'll probably assume that it's a class. But yeah, so within a class, you can create class attributes. So this will be available to the entire class as a whole. And you can also initialize a function, initialize a class with some variables that will become instance attributes. So every instance that is created will have these unique attributes to that instance based on what was sent in when it was created. So if I wanted to create 2 instances of dog, we can have one dog have this information, and then one dog have this information. And this is attributes. Oh, we forgot the sound here.
I think he's missing a color, actually.
What is it? So name, breed, color. Ah, yes, yes. I would say, oops. What was Scooby-Doo? Brown, spotted.
Brown.
Brown and black, yeah. Brown works. Okay, so now we have access to the instance variables. Any lingering questions from yesterday on like class variables versus instance variables or attributes?
Yes, I was trying to add a class variable
Mhm.
that would add into the int part, the int function. And it
Okay.
wasn't, it's giving me the squiggly lines.
So what were you trying to do for the init function? Like,
I made a class variable for the email domain.
Mhm.
Like at code, so email domain equals code platoon.
Yeah.
And then when I tried to add it into the int statement,
Mhm.
or into the self.address, so it was like first name plus last name plus my variable email domain, it was giving me the squiggly line.
Mhm. So when you put the same name here, like if I was sending in species like this, or when you were trying to use it in here?
Where you're at right now.
Yeah, okay. So to access any variable that is available to here, you would have to put self. Inconsistent use of tabs.
I didn't add it into like the input variables for the int. I'm seeing that you added it like after sound.
Okay, let me see real quick. So sometimes if you copy code from the internet, it'll give you like inconsistent tabs and spaces and stuff like that. So you might have to just go back to every single one. So now it's fixed. Okay, so I'll remove species here. And let's say I was trying to access it. Yeah. Let me try printing this out when it gets to here. So when it's initializing everything, we can just print out species, which it doesn't know what it is. So self dot species will hopefully work. Okay, it seemed like it was printing out something. So I believe you just have to use the self, and that's how it will know where it is. Because self refers to the instance of the class, but the instance still has access to the class variables as well. So if I'm printing out here, this is inside init. So here,
Self
inside
dot
init.
worked.
Sorry, you said it worked? Or
Yeah,
no?
adding self dot
Perfect.
work.
Awesome. Yeah, great question. Any other questions? Keep missing some of the chats, so I'm just going through them. Okay. Okay, so there's just some discussion on the decorator chaining. Awesome. Okay, so we know that there's two different variable types or attribute types in a class. There is also different method types. So when we've been creating methods, so if I said speak, these are called instance methods. They are just regular methods that take the self variable, and then they return something, whatever you want it to return. So let's say here for this function, I want to print out self.sound. And so, oops. Just gonna define the two dogs. And then if I say Lassie.speak, okay, I can actually delete this print inside the init, but basically it just calls the function and uses the variables inside. So yeah, just like some of the attributes can belong either to the instance or the class itself, methods could also belong either to an instance, which is what we see here. This is an instance method, or the class itself with something called a static method. In Python, we also have access to a class method, which is very similar to a static method, but I don't think is used as often. So let me show you an example of this. So here, I'm just gonna do a little divider. Okay. So let's import this. So let's say we have a class for pizza, for just to hold information on pizzas. Whenever you create a new pizza, you have to give it the radius and what ingredients you want. And then it'll hold that information for you. And there is an instance method called area that will give you the circle area, or it will calculate the area and save it into, oh, my bad, I'm so sorry. It will calculate the area by calling this method with the radius. So this method here is called a static method. So static methods are available to the class as a whole. So you can call them from outside of the class and not have them really be specific only to this class. So sometimes it's useful to have access to the class itself in a static method. Sorry, that was not what I want to say. But basically, this just generally calculates circle area. And let's say in your program, you need a function that calculates circle area maybe like once. And it makes the most sense to have it live in here, but maybe you need to access it from outside, or even in this case, you want to call it from within. You can make it a static method. So this static method will be available to the class. So if I instantiate a pizza, and then I need to send in a radius. So let's say 8, and these ingredients, I'm going to make a list. So let's say mushrooms, which should be a string.
Pineapple.
Pineapple. Very controversial.
How dare you?
But yeah, let's say this pizza has mushrooms and pineapples. So if I print my pizza dot, dot area, it will automatically create the circle area for me. So if I run this, so what did I do wrong here? When I ran this, it printed this out.
You didn't call the
Printed
method.
Yeah, you can call it.
Exactly. I didn't call the function itself. I just tried to print out what it was. Let me just clear my terminal so it's less crowded. And there we go. So it calculated the area. It used the circle area function. Let's say I wanted to use the circle area function from outside of this class. I could say pizza, wrong place. Dot circle area, and then it needs a radius, so I can just give it like 6, and when it returns, I can print out the return of that. And so I was able to access the same function from inside of here, from outside, from the class itself. So a static method allows you to use a method that's within the class outside as well. Sometimes, yeah, actually, I'll leave it here. Any questions?
So if you didn't have that static method above it, you wouldn't be able to do a dot circle area. Is that what you're saying?
This one here, let's see. Pizza.circle area. Yeah, so self is referring to the class, right? And then it needs to know about circle area and have it be, what is it called? Accessible here. So I think if it was, so it takes one positional argument, but 2 is given. If you want to actually make it an instance method, so you can just add this and then it will work. So whenever you send a self in, that means it is going to be attached to a specific method. But now if we
And
want
then
to,
outside,
sorry.
and then you're already doing it. I was gonna say, and then outside, does it work like that as
Yeah. So here, it doesn't understand if I'm calling pizza.circle area what it is. It just has to, so even if I remove the self, it still doesn't understand what it was because I need to turn it into a static method. So it's saying that it takes one positional argument, which is the radius, but 2 were given because we are referencing the class itself. So if we put the static method decorator here, then it will understand what it is.
So everything could be a static method, and then you don't have to use any self.
Say that one more time, sorry.
So if you use static method on everything, then you don't have to use self at all.
Yes, but that is not, it's, yeah, you don't want to do that. A lot of times you want to keep the functions tied to a specific instance because they will be accessing information that was created by the instance itself. So here, circle area is not using any sort of instance attributes, if you notice, right? So area does, so that's why we want it to be an instance variable. It needs to have access to self, versus circle area, it's not really doing anything specific. It's just calculating some math. So you can have it be a static method and not have it need the self. Other questions? So yeah, static method here is going to convert a function to be static. And it does not receive an implicit first argument. So that means it doesn't receive the self first argument that is implicit in all classes. So yeah.
So really quick, this might be out of concept, but is that the same thing as public and private methods, or are those similar in vein?
I think they're a little similar. I don't know if they're implemented the same way, but basically, actually, public and private methods, these are typically like in Java or C or is it C or C++? What are those languages?
C.
C, yeah. Basically, you can set the permissions on this. So if you make it private, that means that only the methods inside of the class can use it. So it is a little different. Versus if you have it public, then you can access this function from outside. So you can call it like this, you can call it like this. That's what it means for it to be public versus private. So private would not be available to the person who is calling the function on the outside at all.
And you'd be using underscore for Python?
Underscore for like this?
Private?
Yeah.
Right.
I'm pretty sure you can. So yeah, so now when I did it, this got grayed out. Oh, it's because I'm trying to call it. But if I'm, oops. But if I do it like this, it still recognizes it. Okay, so it's just not liking this. Let me show you here. So yeah, you can change it to an underscore. It just becomes something that the user who is trying to call this function, they're not gonna find that function immediately. So they're gonna assume that it's not to be used. But technically you can use it. So it's not fully hidden. It's not fully private. And we'll talk about the like variable stuff in a bit, like getting variables and stuff. Okay, one last thing I want to mention before we take our break is the class method. So class methods are very similar to static methods. It allows you to access it from outside of the class. So you can just use the class, and then you can call the class method that's in there. The only difference is it has an implicit variable. So it will take an extra variable that is going to refer to the class. So it's not going to refer to self. It's going to refer to the class itself. Versus self is referring to what?
That particular instance.
The instance.
Exactly. So the particular instance is what we use for self. And then with the class method, it gives you access to the class itself. So let's say I wanted to, so this is typically used if you want to create methods that instantiate like specific instances. So let's say within our pizza example, we want to create some methods that will automatically create like a margarita pizza and a prosciutto pizza. So like those are we already know which set of ingredients it needs, so we don't actually have to do it like this. So here, so this is how you can define it. You just add the class method on top. And when you do that, it gives you access to the class. So it gives you access to pizza. And here we're just naming it CLS. I can name it actual class, class. Oh, class is a reserved word. So when you see it change like this, that means you can't really use it for anything. So let's just keep it CLS. So now you can use this to instantiate a pizza. So let's say it'll also take a radius, because that's what our current pizza initializer takes, right? It takes a radius and then ingredients. So let's say we only want to take a radius for our margarita pizza. We'll send that in, and then we'll send in a very specific set of ingredients lists. So I can define the same thing for whatever pizzas I want to have built in pretty much. So here I'll send in the radius. Oops. Okay. So now if I wanted to be out here and I wanted to say, create me a margarita pizza. So I can say my pizza equals pizza dot margarita, and it takes in a radius. So let's say I want a 9-foot pizza. And then we can, what can we do? Let's print out the ingredients. So print my pizza dot ingredients. Right. Yeah, ingredients. I'm gonna comment these out. Okay, so margarita pizza, it created a pizza for me with these built-in like preset ingredients. So that's sometimes like the use of it if you need to instantiate a specific version of the class. Questions on this?
Yeah, so you have the class comma radius, right? And when you're doing the class method, and the class, just trying to understand, because we only passed in 9, and margarita is, yeah, just a little twisted on it.
So this class variable is similar to the self, in which it is implied when you are calling it. So CLS is going to give you access to the class that is before the dot. So similar to instance methods, when I wanted to call an instance method, I had to have an instance that would then refer to that function. So in area here, self is referring to my pizza, which was before the dot. Versus in a class method, what is before the dot is going to be the class name. So that is the actual class itself. And that's how we can use it to instantiate a new version of it or a new instance. Does that make sense?
Yeah, so if you, like, for instance, didn't pass in the radius and because you added that afterwards, like from the copy paste, right? So if you just didn't have the radius in there, it would know that mozzarella and tomatoes, you're making the pizza with that.
Yeah, so why do you think I added the radius here when I'm calling this?
Yeah, that's it. Is it because of the class initiates an radius?
Exactly.
Okay.
So in the example, it's a new pizza class that doesn't have the radius at all.
Got it. Okay. Okay. I didn't look up the other
Yep. No, exactly. I agree. Yeah. So that we added the radius because that was the one thing that was like extra that we wanted to take in. But if we weren't taking any radiuses, then we could just instantiate it. We don't need to have anything taken in from the user. So we can just call it like this, and it will create a pizza for me. But this one does need it. Other questions?
Okay, one last one. Could you do something like pizza dot margarita dot circle area? Something like that? Or
Let's see. So this is, you have to be careful when you're chaining things. So pizza dot margarita will return an instance of a pizza, but now it'll use this instance that it returned and then do dot circle area. So my pizza is not going to be an actual pizza, it's going to be area. So area, and if we print it out, it's missing a required argument. So circle area takes in a radius. So we could probably call this area function instead. Actually, no, we can just send in 5 and let's see. So it does work, yeah. But then this is referring to this instance here. And one more thing to mention with static methods can be accessed from inside and outside the class. So here you see this method is using the circle area method inside, but we can also, like we saw earlier, we can just use it from outside the class by accessing it through the class name itself. Yeah, questions? Okay. Let's take a break. Let's do 15 minutes. Let me stop the recording real quick.